Hello, everyone, and welcome to Monday Learning. We are doing a workshop webinar on analyzing Apache Cassandra data with GPUs, and we are joined by some fantastic colleagues of mine and a special guest. So that's without further ado. If you guys can hear us and see us just fine, why don't you give us a thumbs up in the chat? Just want to make sure that the stream is working well. But as we do that, let me introduce to you to some of our presenters. All right, let me make it small as well. All right, we have with us some of my colleagues here at DataStax. Alex, Kai, why don't you introduce yourself, Alex?
Sure. So hi everyone, I'm Alex Kai. I'm a software development intern here at DataStax. I've been working here over the summer, and yeah, I'm pretty excited to show a little bit about what I've been working on. Hopefully you guys will find it exciting as well.
All right, thanks, Alex. And then we also have Sebastian Estevez. Hello, Sebastian. How are you today?
Hey, folks. How's everybody doing? Yeah, Alex has been doing some great work for us. And yeah, I've been with DataStax a little bit longer than Alex, about 7 to 8 years. Great to spend some time today with you guys talking about analytics.
Yeah, it'll be really fun. And we have our special guest from Nvidia. Welcome, Justin. How are you?
Doing great. Thanks, everybody. I'm really excited. We've worked with Alex and Seb here to kind of integrate Rapids to kind of show the full utility of what Rapids can offer. And I'm really excited to see what Alex has done, or at least have him show it. So great work.
All right. Thanks. Looks like we have some thumbs up in the chat. Means we are coming through loud and clear. All right, let's get to just a little bit of housekeeping. I won't take too much time. So we are streaming on YouTube, but if YouTube has any issues like stream quality or latency or whatnot, we also have a backup stream on Twitch. Now, we don't monitor the chat on Twitch, so if you have questions, make sure to use the YouTube chat. Or if you would like to join our Discord channel, we have a growing community. I think we're close to 20,000 members now, which is crazy. I'll put some links in the chat for that. You can join our Discord. You can also ask questions there. You can ask more long-term questions, maybe about Cassandra specifically, and we're pretty active in there as well. Today we are going to do some hands-on. We're also going to do a quiz at the end where you have an opportunity to win some prizes, some swag. So we'll be doing a kind of a game at the end there. So stick around for that. We'll have more information on how to do that, but we'll be using a online tool called Menti. It's really easy to use, and we'll walk you through that when we get to it. All right, so for the hands-on, a few things to note. We will be using a GitHub repo. I'll put the link in the chat for you right now. Everything that you need is there, and when we go through the hands-on, we'll kind of walk through that. You will need Docker in order to run the hands-on. If you don't have Docker, feel free to either just sit back and watch and learn, or if you'd like to install Docker while we're going through some of the content, it shouldn't take too long. So you can do that as well. But you do need Docker to do the hands-on. All right. Without further ado,
it's probably a good idea if you are going to do the hands-on to pull up the README that Ryan shared and actually run that Docker pull command, because it's going to take a few minutes to pull depending on your internet connection. So if you want to start on that while Alex gets us started, that's a good idea.
Yeah, that's a good point. It's a pretty big Docker. So if you are interested in doing the hands-on, go to that GitHub link and get it started to download now so that you'll be ready. All right. With that, without further ado, let me hand it over to Alex, who's going to present our content today.
Sweet. Okay,
all right,
so
take it away.
Hi everyone. Yeah, I'm Alex, and yeah, today I'll be talking a little bit about GPU accelerated analytic queries on Cassandra with Rapids. So if there's words there that you don't recognize, don't worry, we'll go through them throughout this presentation, and hopefully by the end you'll have a good sense of what it is exactly that we've been working on. So today we're going to have sort of 4 main sections. So first off, I'll talk a little bit about SS table to Arrow, what it sort of does, what problems it solves. Then we'll talk a little bit about Rapids, which is, or what it is, we'll get to it in a bit. But it's essentially some open source Python libraries that can help you run data analytics on a GPU. Finally, or not finally, sorry, Thirdly, we will go ahead, do the hands-on demo with SSTable to Arrow. So make sure, yeah, you start pulling that Docker container or the Docker image because it is pretty big. My apologies. And then finally, we'll do a little demo of how SSTable to Arrow works with Rapids. And so since this only works on machines that have Cuda support, so with a GPU, I'm guessing that most of you will probably not be able to follow along, unfortunately. So this will just be a sort of demo to show what SSTable to Arrow is capable of. All right, let's go ahead and get started with introducing SSTable to Arrow. So first off, hopefully you guys are all here because of how awesome Cassandra is. And if you guys haven't heard of it before, now is a great time to get started because Cassandra 4.0 has just released, which is pretty exciting. And I'll talk a bit about what that means. So Cassandra, just to recap, is an open source, NoSQL distributed database. And because it's distributed, and that means the data is replicated across many nodes, it has massive horizontal scalability. It's extremely reliable and also very fault tolerant. So if you're building really large applications, Cassandra is a great choice because it can make sure your data is always available and really easy to access. We here at DataStax have been really closely connected with Cassandra. We're sort of one of the leading Cassandra experts, and we also offer serverless Cassandra as a service through DataStax Astra. And yeah, like I just mentioned, 4.0 just released. So if you're just getting started with Cassandra, now is a great time to check it out. OK, so Cassandra is great for transactional queries. So those are queries that essentially look at maybe one row or a couple rows inside the database. For example, if you wanted to ask, I have this user ID. Can you get me their username, for example? That would be an example of a transactional query. And Cassandra is really good at those. It can search through the table, get you the information that you need really, really quickly. But what if, let's say you already have a lot of data collected in your Cassandra table, and you decide that you want to do analytics on it? So this could include things like statistics. It could include things like machine learning. So what if you want to do analytics like machine learning on that data? So since Cassandra itself isn't really natively really good at this, there are a couple external sort of tools you could use to get that working. So one tool that a lot of people use already is Apache Spark. And Apache Spark is a parallel processing framework for doing distributed computing. So it essentially, very similar to Cassandra, it's distributed, so it takes place across many nodes and allows you to do those sorts of big data operations effectively. However, in case you haven't used Spark before, it can take some effort to set up. And also, what if you have an existing analytics workflow using Python libraries that you want to run on Cassandra data? So nowadays, Python is sort of the de facto standard for doing machine learning and things like that. So you're probably familiar with names like pandas, NumPy, maybe scikit-learn. What if you already have code using these libraries that you want to run on data from Cassandra? So in that case, you can fetch the data from your Cassandra table using a driver and then run analytics on that data. So you can see here on the screen, we have a little example of what that looks like. You can essentially use Python, connect to that cluster, transform the data into a pandas data frame, and then do whatever analytics you want on it. And this is a pretty small example, getting like the mean of a couple columns. But you can imagine this would integrate right away with things like scikit-learn, NumPy, other libraries that you might need. However, using that second approach, using the Cassandra driver, does have some drawbacks. So for large data sets, if you're querying the entire data set, it can be expensive. And we don't want to slow down our transactional operations. Imagine you're some big company and your users are using, for example, some real-time application that queries your Cassandra table. Well, if while they're querying their Cassandra table in that real-time application, if you're sort of asking the database to do this really, really big operation, it's going to slow down that sort of real-time experience. And we don't really want that, right? Because that's bad user experience. So how can we extract data from Cassandra without using our main Cassandra cluster? Because remember, we don't really want to put a load on our Cassandra database, our Cassandra cluster. So we want to extract the data directly somehow. So how to do this? Let's take a look at how Cassandra manages data under the hood. So Cassandra, it stores most of its data inside memory. So memory tables, when you actually query the database, that's what it uses. But when you save the file, or when you save the data to the disk, if you want to persist it for long-term storage, it stores it in the form of SS tables, or sorted string tables. And you can see here on the left, an SS table is essentially this big collection of a bunch of different files. You can see we have some compression info, we have the actual data, some statistics about the data. All of that is stored in these SS tables. And Cassandra, what it does is parse the SS tables to get that data and then send it to you, whether you're using SQL or you're using a Cassandra driver. But like we said earlier, we don't want to put load on our Cassandra database. So the question is, can we fetch data directly from the SS tables without using Cassandra? And this is what I've been spending most of the summer working on, because it's not so easy. So here's a few diagrams of what SS table files kind of look like internally. This is all binary data, so sort of ones and zeros. So I sort of read through the documentation, figured out how to parse everything out. But even though it's difficult, of course it's possible, right? Because how else would Cassandra work? So this is kind of what SS table to Arrow is for. So SS table to Arrow is a tool that parses data directly from SS tables. And I have here a little example of the Docker command. Don't worry about it. We'll get to that in a second during the hands-on demo. And it's open source, so you can go ahead, find it on GitHub. Look at my source code if you're so inclined. And yeah, so essentially that's the essence of what SS table to Arrow is for. It can read those SS tables directly without having to go through Cassandra, and then it transforms the data into this format called Arrow, which we'll talk about in a second. So, oh, I missed the recap. So just to recap, let's say you have a lot of data stored in Cassandra, inside a Cassandra table. And everything has been going well for your transactional needs. So for example, real-time applications that are querying that table, all of that's going great. But one day you ask, how can I extract insights from this data using analytics? And previously, or you still have these, but of course, SS table to Arrow is a different option. So you have two sort of main options. Firstly, if you're using DataStax Enterprise or Cassandra open source also works too. You can use Apache Spark, which is, once again, a distributed framework for computation. So distributes your computation across many different nodes, and that allows you to scale and do that sort of analytics really efficiently. But this does require a lot of setup, and you would need to migrate existing analytics code that isn't written with Spark. Excuse me. So if you have existing Python code, for example, using things like NumPy or scikit-learn, you would need to migrate that into Spark code. The other option is you could fetch all of the data using a driver and then run analytics on it using your framework of choice. But this requires querying the Cassandra cluster, which will slow down your transactional operations, which once again we don't want. We need those transactional operations to be lightning fast. But now with SS table to Arrow, as long as you have access to the underlying SS tables, you can easily query for that data without burdening your instance of Cassandra, and you can easily migrate existing Python analytics code using Rapids. Okay, so now let's take a look at what is Rapids and why should I use it, or why should you use it? And yeah, this will be a look into GPU analytics using the Rapids ecosystem. So Rapids is a suite of open source software libraries, and it enables end-to-end data science and analytics pipelines entirely on GPUs. And under the hood, it uses Nvidia Cuda to optimize low-level compute. So Cuda is essentially a programming toolkit / language that allows you to write code for the GPU and make the most use out of its power. And as you can see here, here's a couple of the more widely used Rapids libraries. And one of the most important ones here is cuDF. So if you're familiar with Python and you've used pandas before, which is a library for essentially managing your data in the form of data frames, cuDF is kind of the equivalent of pandas in the Rapids ecosystem. And it allows many of the same operations, like storing data or querying for data, or all of the notation you're probably familiar with. That's all stuff you can do with cuDF as well, except it works on the GPU instead of the CPU. OK, so why are we so concerned about using GPUs anyways? What's the big deal? So as you can see in this diagram from Rapids, it is a pretty big deal, because GPUs are able to do these analytics processes and machine learning training, for example, much faster than current CPUs can. And the reason for this is that GPUs are essentially able to multitask very efficiently. You can run like lots more different threads on a GPU than you can on a CPU. And since data science and machine learning requires a lot of parallel computations, GPUs are much better suited for this task. So as you can see here, they're very performant when it comes to doing things like machine learning and data science, which is why we want to use them for what they're good at. So if we're doing data science and you have some code that's already written, for example, with pandas, scikit-learn, maybe matplotlib, all of these have respective equivalents in Rapids. And that makes migrating your existing code really easy. So as you can see here, we have cuDF is essentially the equivalent of pandas. We have cuML, which is essentially the equivalent of scikit-learn. And we have a bunch of other libraries that can help with all of your data science needs and enable you to run data science from end to end on a GPU. So I'll go back to take a look between these slides. And you'll notice, one other difference between these two sort of pipelines is the type of memory that they use. So currently, these familiar Python APIs are running mostly on your CPU, right? So that's the memory that you sort of have inside your computer. But with Rapids, it allows you to interface with GPU memory. And like I mentioned earlier, the format that this memory is, that your data is stored in, is known as Apache Arrow. And Apache Arrow is a really cool project. And now I'll hand it over to Seb and Justin to talk a little bit about Apache Arrow. All right, go ahead.
Yeah, so I guess I'll kick us off. So Arrow is a project. It's been around a few years in the Apache open source governance model. And basically the main thing that it does is it's an in-memory a data structure that's columnar based. And so it's designed for a couple of main things. Most columnar data formats in general are designed for analytics. This makes sense because the kinds of things you might want to do in analytics is compute statistics for a particular column. And so you may want to fetch an entire column's worth of data to be able to aggregate it at a time without looking at or going through other columns in your table. So that's kind of one of the main purposes. The second kind of and more important thing that makes Apache Arrow unique is it's a cross-language in-memory implementation. And so it comes with a set of tools for whatever programming language you may fathom, right? Your favorite language, to be able to parse and manipulate and create these Arrow data structures. And so the folks that built Rapids have pretty heavily piggybacked on this Arrow technology. I think Justin's going to go deeper into a little bit of that on the analytics side. Arrow is a really interesting project for folks that are maybe running Cassandra or other databases or are interested in kind of the transactional side of the house, just because of that capability of going from language to language or even going over the wire without having to serialize or deserialize the data. Right. So traditionally, let's say that you're building an app and you have some data in an object format in your particular programming language. when you want to send it over the wire or send it into the database, you serialize that into a format that you can send over the wire. And then you, again, deserialize, deserialize again, very basically at every step to turn it into objects in your code, whether that's the code inside of the database, like Cassandra, that's going to stick stuff in what we call mem tables, which is the Cassandra memory format, or whether that's the code inside the driver that you're using to either persist or read the data. You're serializing and deserializing constantly, right? And so if ecosystems like, for example, the Cassandra ecosystem adopted and leveraged Arrow, it's possible to do that throughout like that entire stack. So there's a potential future in which everything's Arrow, starting at your driver application and going over the wire to the database. And there would be literally zero copies made of the data, zero serialization, deserialization, which actually takes up like a chunk of the compute inside of systems like Cassandra, right? Both at the driver level and at the database level. So this is a really interesting technology. I think we've been watching it for a while, and the guy that came up with the name, he actually works at DataStax. So it's a pretty interesting technology from just a compute database perspective in general. But really, it's optimized and designed for analytics, and I'll shoot it over to Justin there to chat a little bit about that.
Thanks, Ed. Yeah, it's an opportunity to have a shared data object between a variety of different APIs, but also different types of hardware. So when most users are coming into data science, the first kind of structural component that they are introduced to is the data frame, and inherently with the data frame they're using with data science is often a pandas data frame. And with most cases with that, when that was first created, there wasn't really a lot of options. So in most cases, you were dealing with a lot of structured data. This is maybe 12, 13 years ago, and just doing your initial data ETL, wrangling, data exploration, doing a lot of your model development using scikit-learn, things like that, but building it on top of the pandas data frame, and then generating some type of analysis, and then at that point, moving on to the next step, or swapping out different types of samples for your model. As we've seen growth within the data science community, the different types of tools that have come up, one of the things that at least was generated was that there were some inherent shortcomings associated with pandas. And Apache Arrow looks to at least address some of those shortcomings, and then have any other APIs or applications that are developed on top of it to be able to avoid some of those pain points that users kind of face right now. And whether that's in-memory computing, whether it's running out of data sets or shortcoming data sets just based on what's available in your CPU. But when Rapids was first created, the core component that was recognized that we needed to understand to at least develop and understand how to create a GPU-specific data frame was, one, understanding that users are familiar with pandas and the pandas API, but also we need to evaluate the same column or structured style that would run on a GPU, and therefore be able to process all this data without having to pass data from or do all the wrangling on a CPU and then pass it to a GPU for any type of accelerated computing. Hence the QDF functionality, where you can essentially take your data, query it from the SS table, put it into a QDF with the backbone of it being Apache Arrow, in this case, a Pyro functionality with the Python API, and then start to do your data wrangling and accelerate all this process of feature analysis, data prep, so on and so forth. And then before you push it into a deep learning specific type process or a more classical machine learning type process using our QML. So these are the types of things that we see are more of an evolutionary growth in terms of what other components are out there within the field that offer assisted components or assisted compute, as well as additional functionality and efficiency for a lot of data science users.
Yeah, so I guess one of the things to point out here is if you want to take advantage of GPUs for things like analytics, like there's not a ton of Cuda developers out there, right? That's a very specific niche like knowledge set. You're writing C++ and you need to be familiar with the specific Cuda APIs, and it's hard, right? And so one of the huge benefits of Rapids and Arrow is that if you're able to get something in Arrow, like getting that data vectorized and loaded into GPU memory, etc., is basically free.
Exactly. It's been extracted from the user, And so all users have to know is just that a familiarity with the APIs that are similar to pandas, and the functionality then is mirrored in QDF. So the same types of steps that you would do in a pandas data frame can be done in a QDF data frame. Therefore, the learning curve is flat.
Yeah, awesome. So thanks so much, Seb and Justin. And I'm going to skip ahead because I think I misordered my slides a little bit. But just to follow up with what Seb was talking about, yeah, that's was we got this tweet and saying, weird that the title of the post is about doing things with GPU, and the GPU part is kind of like a to-do at the bottom. And what makes Arrow so great is that that's kind of exactly the point, is that for most users who don't need to worry, most users now don't need to worry about the actual process of getting data onto the GPU, because the Rapids ecosystem and cuDF and cuML and all of these libraries do all of that work for you. So really, on our end with SS table to Arrow, the main idea is to read those SS tables and get them into Arrow format. Because once they're in Arrow format, we can use them on the CPU, we can use them on the GPU, and it's just a very flexible format we can use also across languages. Okay, yeah, awesome. So I'll just back up to those two slides there. So yeah, here's just a sort of brief look at what we're talking about. So if you already have some code using pandas, for example, we're just reading a CSV, printing the mean of each of the columns, pretty basic stuff. If you want to run this code on a GPU, all you really need to do is switch out pandas with cuDF. So now instead of import pandas, we just have import cuDF, and then all of the other, all the rest of the API, we can essentially use it in basically the same way. So Rapids is a really, really great project. Highly encourage checking it out in case you want to do data analytics on a GPU. Okay, so now let's move on to part 3. So this is going to be the hands-on section where you can try out this tool on your own Cassandra data. And in case you don't have an SS table or SS tables available, don't worry. First of all, we have some sample data bundled in the repository that you can use. And we also have this S3 bucket with some sample Internet of Things generated data in case you want to use that in a bit. So the S3 bucket is called SS table to Arrow. But for today, I think we're mostly going to be using the sample data inside the repository. But just know that SS table to Arrow is able to read SS tables from an S3 bucket. So if you have data maybe in S3, I've heard rumors that that's maybe where Cassandra will be going in the future too, or Astra. Yeah, so S3, that's where our data is stored. You can go ahead and use that as sample data if you want. Okay, so here's a brief overview of currently how you can use SS table to Arrow. So keep in mind, this is alpha level software. I'm currently actually working on some Python bindings that you can call straight from Python. So I guess stay in touch, keep updated about that in case it ever comes out. But currently, how it works is we have these SS tables on the disk. So we have our data file, statistics file, etc. And that gets read by the actual SS table to library, or SS table to Arrow library, which is written in C++, and which you can run through a Docker container to avoid any like installation pains. And essentially, that tool will take those SS tables, transform them into Arrow tables, and then it'll listen on a network socket that you can connect to actually grab that data. So then on the client side, we have a sample Python script, which you can grab from the repository that we sent out earlier. And that script will essentially go and ask for the data from that server, and the server will send that data back, but as an Arrow table instead of SS tables, which are harder to parse. And once we have that data as an Arrow table, we can do, like we said, data analytics or anything we want with it, basically, using the Rapids ecosystem. So here's a brief overview of the steps. I also just realized I haven't updated this URL for the Python script. So this is essentially identical to what's on the GitHub repository. So Right now, if you want to go ahead, hop on that link that was sent earlier to the GitHub repository and just follow along with the getting started. We'll basically go ahead and walk through that. So unfortunately, I can't read the chat, so I'm not sure how much time this will take. But I'll hand it over to Seb right now for a sort of live demo of how this is going to work, because unfortunately my computer is having some technical difficulties. All right, Seb, do you want to go ahead and share your screen?
Yeah, absolutely. All right.
Okay.
So share screen button over here. I'll jump out of the YouTube there. Okay, so this is the section that we want to do for hands-on. If somebody's if you're watching the chat and some questions come in, just go ahead and break in, and we can answer those. But until then, I'm just going to walk through the steps on how to run this and talk a little bit about what it does. So the first thing was you want to pull the container that has the SSTable.arrow program. SSTable.arrow, I'll show you guys quickly. The repo is written in C++. This is Alex's work for the last few months. And so there's the compiled binary in this Docker container to make things easy. You don't have to go build anything from source or anything like that. But yeah, this is the project where it lives. And basically what it does is you point it at some SS tables, and it makes them available in arrow format. Now, in the example here, what we're doing is we're starting up the container, telling it which SS tables we're interested in, and having it start and having it open up a network socket. And the second section here, this Python part, is a Python client application that's going to hit SSTable.arrow via that socket, ask it for the data in the SS tables. That data is going to be sent in arrow format over the wire. So this not only shows off the ability to read the SS table data, stick it in arrow format, but also sending arrow format without deserializing over the wire. And then it gets turned in directly, like read as arrow directly in Python without any serialization, deserialization. And at that point, this script does some simple analytics on it. So that's what we're doing. The first thing is to pull that container, which hopefully you guys have already done. The next thing is to pull the Python script. It's going to be the client. You can do that with this very simple curl command. I already did that on my machine. Then you want to create a virtual environment just to make sure that we have our own Python installation here that doesn't interfere with your operating system Python. It's just a clean way of doing things and making sure that we don't interfere with your host environment. We activate that virtual environment in Python and install a couple of dependencies. It's just pandas and PyArrow in this case. There's another version of this that does the actual GPU stuff, and that will also install the Cuda libraries. And then we kick off the container, which gets those SS tables read and into memory in Arrow, and we run the Python program that pulls that Arrow data over the wire, does some analytics on it. So let's actually do that live here. This is the Docker run command. For those of you not super familiar with Docker, you may be wondering what this -p thing is. Well, actually, I'll break down the whole command. So we already pulled. That means that on this machine, I've got this image sitting here. Now I want to run that image. --rm means that once this process is completed, I don't want to hang on to that Docker run. I actually want it deleted from my Docker environment. Then IT is passing a command, which in this case is -s. And this -p is telling our Docker to map the port 9143 inside the container with the port 9143 outside the container in my host machine. And so that's what's going to allow the client program in Python to hit the container through the network. So once I kick this off, you can see that it found some SS tables, and then it created a socket on port 9143. So let me pull up another window here. If I, so F-I 9043, we said is the port.
9143. Sorry.
9143.
Oh, I think you might need a space. -I space 9143. -I space colon 9143. Oh.
Oh, you know what? I need to do this as root. Yeah, so
There we go.
Docker is here. There's a Docker process. It's listening to all interfaces, on the port 9143. So this is just a way to validate that. We can also say Docker PS, which shows you that Docker is listening and it's got ports. Then on my host machine, I can see it listening on the port. So these are just kind of some pre-troubleshooting steps in case folks get stuck. This validates that your Docker part is running correctly if you're able to do both of these things. And then I'm going to actually go ahead and kick off this Cuda code. Now, before running the script, maybe let's take a look at it. So it's got a couple of variables here for localhost and the port that we're going to be reaching out to the socket on. There's some functions that are defined, and let's see. So there's no Cuda, but we're going to go through and open up the stream. And once we've got the data, it's going to be in a data frame, and we're going to basically print it out, print the mean of a column called sensor value. So this is the simple analytics stuff that we're talking about. And then this IPC open stream, read all to pandas, reaches out to the C++ program, gets the data over the wire, and sticks it in the pandas data frame. So the interoperability with Arrow is also showing here. So we're going from Arrow to pandas very easily. In the GPU code, we go from Arrow to QDF very easily. Same deal, right, to pandas to QDF. You'll be able to see that if you take a look at the with GPU code. So this is what the program does. Let's go ahead and run it. All right, so I loaded the table, and we spat out some columns. In this case, we have a partition key, which is a UUID type. We have some row liveness, and we have some times. And you can see here that we calculated the mean of sensor value of a few rows. I think there's 1,000 rows, right? They got read in this example SS table. If you have your own SS tables that you want to parse and manipulate, you could pass a directory with those SS tables to this program. There's more information in GitHub on how to do it, and we'd also be happy to, help out there if you want to reach out to us.
Yeah, awesome.
Yeah, so this is what it does. I guess I'll add a couple of other points that might be interesting to Cassandra folks if there's no questions at this point. One of them is the liveness. So one of the interesting things about a Cassandra table from a data storage perspective, Alex was mentioning as data goes into Cassandra, it goes into a mem table and a commit log. Before we acknowledge to the client that data got written, it's going to be stored in, it's going to be persistent on disk in the commit log, and then it'll also be in memory in a mem table. Those mem tables fill up and they get flushed into SS tables, and SS tables are what we're looking at. So one, from a kind of caveats perspective of the project, if you were doing this against all the SS tables in your Cassandra cluster, one, you wouldn't be getting the real-time data that's in mem tables as of that point. So based on the software that's been developed up to now, it's going to be very useful for performing analytics on Cassandra data based off kind of a snapshot, but not like the latest data. Another thing that's kind of a caveat to keep in mind is a Cassandra table is going to result in lots of SS tables on disk. And not only lots of SS tables on disk in one place, but lots of SS tables on disk across lots of machines. And so you do need kind of a way to consolidate all of those and hit them with SS-table to Arrow to get useful data. Secondly, Cassandra uses a log structured merge, right? So so that's what SS tables are. They're data is a data storage format that's basically a log, and SS tables are immutable, which means that if you have updates in your data, you may have values for the same unique key across a couple different SS tables, and Cassandra on reading will basically pick the latest using last right win semantics. And so SS table to Arrow doesn't do last right win semantics for you yet. What it does is it exposes the internal timestamps of all the cells in the Arrow in the Arrow in-memory structure, and then as a user, you can write some SQL to say, I would like to get the latest timestamped rows, or the latest timestamp cells for the rows that I care about. So that's kind of the stage that the process is on. Again, it's very useful in kind of first few steps, lots of steps into this kind of journey of making Cassandra data available on GPUs. But there's certainly lots of work to be done as well. And whether we continue to do that and invest, I think hinges on how interested folks are, right? So we're very excited to hear from people about what they think about this and whether they want to pursue it for their real use cases. And we'd love to hear from you and chat more about it and see how we take this into the future.
Yeah, awesome. Okay, thanks so much, Seb. All right, I'm gonna go back to sharing my screen.
Do we have any questions at this point in the chat at all, or folks trying it?
I can't see the chat, so I guess if you guys have any questions, Seb, if you can I guess redirect them if they're specifically for me.
So real quick, I just wanted to, I'm popping back in. We do have a few questions, though I know Justin has been in the chat answering a lot of them. I was wondering, Justin, if you wanted to, I know you answered the question about the analytics on GPU versus otherwise. You kind of had a longer answer. I don't know if you wanted to talk about that more.
Sure.
To everyone.
One of the things we want to convey is that what Alex has done, at least from the SS table to Arrow, is that you can analyze the data on a CPU, but also a GPU. Now, say you are an analyst, data scientist who is attempting to do some code on a smaller data set. You access the data in SS table. You go through your data science order of operations, essentially, the data exploration component, identifying, which features are correlated or decorrelated, putting it into essentially a more data subset that you then run a smaller model on, maybe just a standard tree-based model, random forest or something like that. But now, understanding that because your code has a specific logic, you don't necessarily now have to worry about converting it to PySpark code or something like that to perform additional analysis to scale up or scale out. You can essentially take your code using the APIs, similar to the example that Alex showed previously, where it's just a minor syntax change. It's just literally importing one package versus another, and then that code will essentially now run on a GPU. So then you can take your process, and now if you want to automate this process or have it run it in a cloud-based orchestration, or have this process run on a GPU on the cloud, you can know that it's going to follow your logic, and you won't have to necessarily worry about any other types of logic adjustments that you'd have to make by converting it from running on a CPU to a GPU. So there's a interchangeability available there between the two APIs.
Awesome.
Okay, sweet.
It doesn't look like there are any other specific questions. And for the viewers, give us your questions, please. We have plenty of time today, so if you have any questions, stick them in chat, and we'll answer them on stream as well. All right, back to you, Alex.
Okay, sure. So yeah, now we'll sort of go through. So you guys have hopefully gotten a chance to try out SS table to Arrow on your own machines, but in case you don't have a machine that is compatible with Cuda, which is, once again, the sort of framework that allows you to interact with the GPU, we're going to do a little brief demo of how SS table to Arrow can help get data onto the GPU using Rapids. So if I go ahead and share my screen here and open this up, Is everyone able to sort of see that okay? Sub, is it visible on the stream?
Yeah, looks good.
Okay, awesome. So yeah, like we sort of mentioned earlier, Rapids allows you to sort of take existing code that you might have with Python or popular libraries and easily run that on the GPU instead. So what we have here is I've taken the Iris dataset. So hopefully those of you who have tinkered a little bit with machine learning, you might have encountered the dataset before. It's essentially a dataset of iris flowers and has data about, I think it's their petal length, petal width, sepal length, sepal width, and then their species. And so there's 3 different species, and it's a pretty classic sort of classification problem, which is where you ask the computer to look at a bunch of data and then try to classify new data into being, a member of a certain class. So scikit-learn, which is a Python library for the CPU mostly, that does machine learning. It already has a couple examples of using the iris dataset for some simple classification. And I was thinking we could use ssstapled arrow to show how you might, if you had that data in a Cassandra table, for example, how you might take that data and load it onto the GPU using Rapids. So here this isn't my local machine. I'm logged into a remote computer. And yeah, so we're importing a bunch of libraries. And then this is the same command that gets run in the no QDF version. So it'll basically fetch the data from ssstable to arrow. So if I go ahead, open up my command line here, zoom in really close. If I go ahead and here, let me close that up. Run this function. So ssstable to arrow, that's the same thing you're running from your Docker container. I just have it installed on this computer. So I'm just running it from the command line. So ssstable to arrow, and then I have this flag -c. Oh, by the way, I should probably mention that. So if you want to see more options about how to use ssstable to arrow, you can also pass the help flag, and it'll print out a bunch of like different flags. It's a really big help message. Yeah, so some other things you can do. You can also write to a Parquet file. So Parquet is another file for storing analytics columnar data. You can also do a dry run, so turn off the listening on the network part if you want to just like print out what the ssstable looks like. And then anyways, this one I'm using right here, -c, just doesn't include the metadata. So all of the timestamps and stuff, it just doesn't include those. So as I mentioned earlier, ssstable to arrow doesn't do any of the deduplication stuff for you as of yet, unfortunately. We're working on it. But so for this table, it's just some sample data that I've imported. It doesn't have any additional writes and things like that. OK, so if I go ahead and run ssstable to arrow, and I've passed the path to my iris data set here, you can see blah, blah, blah. There's a bunch of ssstable files. And this is also compressed, by the way. So ssstable to arrow works fine with compressed ssstables. So if we go ahead and run that, you can see, there we go. It'll read the ssstable, listen on the port. And now in my code, if I go ahead and fetch the data, awesome. So it receives that table. And if I want to sort of print it out, table 0. Yeah, awesome. So we can see here we get all of that data. And if we want to load it into QDF, we just call qdf.dataframe.fromArrow. And then I'm passing that one table that we loaded. And I'm just renaming some of the columns here to make it a little bit nicer. And woohoo, you can see we've grabbed the data from our ssstable and parsed it into QDF. So once again, QDF is sort of the equivalent of pandas that holds all that stuff on the GPU. OK, so next up, I've taken this scikit-learn example from the scikit-learn website. And like we mentioned earlier, I've just exchanged sklearn with QML. And that's, I was like, wow, this is kind of magic. So sklearn, exchange it with QML. There's a couple minor changes with the QDF sort of syntax. And I'm also using matplotlib to plot it, which requires NumPy arrays. So there's a couple minor sort of changes, tweaks I have in here. But essentially, you can see here, we take that Cuda data frame, grab the data. So here I'm taking some of the features, and then I'm also taking the target. If you guys are familiar with machine learning, it's probably pretty clear what I'm doing. Here we're using the QML logistic regression model. So we're creating that classifier, fitting it to the data, and then this is a bunch of sort of setup code just to get the plot to look kind of nice. And then if I go ahead and run this, matplotlib gives me a warning, and you can see here it's running. Takes a couple of seconds. I feel like the time is also maybe because of connection to the remote. But you can see here, we're able to sort of classify those data points, that iris data set. So blue is one species, brownish is another species, and then yellow is another species. And all of this is sort of done on the GPU. So yeah, hopefully that gives a sense of what Rapids is sort of used for, and what SS-table to Arrow is used for. And like Seb mentioned earlier, in practice, a lot of the time you're going to have not just one SS table, but a whole bunch of SS tables that correspond to a single Cassandra table. So unfortunately, SS table to Arrow doesn't support the deduplication step, but you can sort of do it manually using SQL on the client side. So one really helpful tool, also I believe associated with Rapids for doing this, is called Blazing SQL or Blazing SQL. And so this is a Python library that allows you to essentially run SQL queries using the GPU. So here I'm sort of importing that library. Let me see if I have my sample data here yet. No. OK, give me 1 second. I'm going to grab my sample data, copy that over here. Did I already have it? OK, I might already have it. Oh, but it's empty. OK, give me 1 second to copy over this data set. I'm just going to stick it in here. OK, cool. So if we go ahead and use SS-table to Arrow again to read that data set, I'm going to copy the path, pass it to SS-table to Arrow, listening on the port, awesome. And I'm going to go back up here to fetch the data again and read all of those SS tables. So you can see this time I have actually 3 SS tables in here. And if you take a look at the numbers, you can see there's SS table 1, 2, 3. And essentially, if you want to take a look at what these look like, they're all corresponding to the same sort of sample key value data. Let me see. I think I could show a visualization of what it looks like. Give me 1 second. Table dot 2 pandas for table in tables. And it'll take some time to run. My computer is slowing down a little bit. OK, so here's a look at what the data looks like. So you can see here in our first SS table, this is the one where I sort of wrote the data. So there's no updates or deletes. So it contains all the data. In this second SS table, I've updated a couple of the cells. And you'll notice that except for the partition key, the row liveness data is mostly empty. And then for that specific cell, we have a timestamp when it gets updated, and then along with the value that it has. And then finally, I've deleted a couple of rows here. And you can see here, it also has the partition key, and it also has the row deletion time. And this sort of, once again, includes all of the metadata from Cassandra so that you can do the deduplication on your own. So if I scroll down all the way to the bottom here, I'm going to use Blazing SQL to read those SS tables. Or sorry, let me back up a little bit and explain this process from the start. So we have the SS tables. and those contain all of the metadata that you need to reconstruct like the current version of your data. And what Blazing SQL does is it can take those SS tables, or sorry, SS table to Arrow, transform those tables into Arrow format. And then we are able to use cuDF to get those Arrow tables into cuDF data frames. And then Blazing SQL is able to take those data frames and load them into its own internal sort of representation so that we can do SQL queries on it. So I'm going to go ahead and create this new Blazing context. Oh dear. Let me take a look at what's going on here. Okay. So if we go ahead and read that key value data. Okay, so that gets loaded into our program. And then we're going to use cuDF to create a table from each of those Arrow tables. Okay, I'm worried it might be some issues with compatibility here. So we might need to skip this part of the demo for now. But essentially, once those tables are loaded into Blazing SQL, you can write a SQL query to essentially look for all of the rows that have not been deleted. And you can also, if you wanted, specify a certain time, for example, and then it will return to you all of those rows and the updated versions of them. But unfortunately, I'm not an expert with SQL, so you might need to do some of those steps manually on your own. But since all of that metadata is provided to you, you can go ahead and write SQL queries to rebuild the sort of current version of your data. Okay, well, I guess that's it for my presentation today. So that's a sort of brief demo of how you can use Rapids. So thanks so much for listening, and I guess now we'll open it up for any questions.
Right. Yeah, I think we have a couple questions. There was a question, I know it's been answered in the chat, but just for the benefit of the rest of the viewers, about kind of a question around speed differences with the GPU versus the CPU and how the data size or dataset size affects that.
Yeah, and I want to say that Seb had a great response to that too, because in most cases it's not necessarily about the data, but in most cases you'll see improved performance the larger the data that you're running through, especially for data transformation, data wrangling that you'd be doing in pandas. The larger the data sets, then you'll be able to process it and do a lot of these transformations much faster on a GPU using something like cuDF. But when we actually start moving into kind of the more classical machine learning, where you're running a random forest or something like that, and you're kind of iterating through all these different variations of the decision tree, in that case, you'll definitely see improved performance running with the QML library versus something like scikit-learn or SparkML, just by either the nature of how the data is being processed and iterated through, or in terms of, for example, SparkML, just the distributed nature of the algorithm and how it has to go back and collect all the different components before it iterates again. So you'll see just improved performance across the board just by the compute that's necessary to achieve the results faster by some of these particular algorithms that Seb mentioned.
Yeah, so to summarize, data volume matters, but algorithm complexity matters as well. And yeah, so with bigger data sets, also with bigger algorithm complexity, you're gonna get big savings from going on the GPU. Something that hasn't come up that I kind of expected to come up, and maybe we should spend a couple minutes chatting on, is like how do we do rapids in a distributed setting? All the folks that are Cassandra users are kind of used to everything running on a cluster, and so maybe folks just take this for granted. So rapids is a distributed clusterable enabled technology. They leverage. Maybe Justin, you can dive into Dask a little bit more. But so yeah, so things to think about, like you have device memory. All these tools support kind of streaming into and out of the device memory in case your data set's larger than memory, and they also support via Dask distributing across lots of machines with GPUs to handle large tasks.
Indeed, yes, and in some cases, so if your data is pretty large that would exceed the memory associated with a single GPU, we use something called Dask QDF, which essentially allows us to use the Dask framework to distribute our QDF data frame across multiple GPUs in a cluster. And so it allows it, at that point, it follows a similar process where now we have also data distribution to run parallel tasks, but in a concurrent fashion that allows us to scale out to additional GPUs to then harness and enhance a lot of that functional power that we get with GPUs, not necessarily just a single one, but multiple. And in some cases, though, even though if you're running on multiple GPUs, it'd be an order of magnitude smaller than just hundreds of CPUs or 50 CPUs or something like that you would have to spin up separately. So in this case, you'd still be looking at improved performance in terms of compute, but also in terms of efficiency and how quickly a particular process executes and then is completed before you can then spin up another process to run. And that's not to say that, you can't necessarily even, this is all just kind of batch processing as well. We have a series of kind of streaming components where we have things like queue streams that we're able to then connect to kind of existing message queues to then be able to capture data in a somewhat real-time component that would then be able to then essentially gather new data and then put it into a data frame for additional execution. And then also, while we have QML, and we've touched on QML quite a bit, additional other types of libraries that are more familiar for CPUs are things like graph analytics. In this case, particularly with Python, you have NetworkX, whereas we also have a QGraph functionality, which allows you to essentially do all your graph analytics and graph processing, put on a GPU and scale it out to millions of vertices and millions of edges, as well as QSpatial for geospatial analysis and QSignal for kind of digital signal processing and time series analysis.
There's a question just came in here about, do we expect metrics to be added to Cassandra for analytics in the future? So just to clarify, like the stuff that we're showing here, I mean, SS table to Arrow, it's not a utility that is in the Cassandra project itself, right? So this is kind of an external third-party utility. It's kind of alpha software experimental that you can use to take your SS tables and do analytics on them separately from Cassandra. In fact, Cassandra doesn't know anything about this. So no, you won't see any metrics in Cassandra about analytics when you use these tools. I mean, there's potential to do kind of more like tighter integrations with things in the future. But yeah, just to be clear, like this functionality, the Rapids ecosystem, the SS table to Arrow software is completely separate from Cassandra. It just knows how to read Cassandra SS tables, and that's the integration point. And we like that being separate because again, there was a question a little bit earlier about kind of co-location versus isolation. So like in some cases, a lot of folks think, hey, if I co-locate my analytics and my transactional, I may get some performance boosts because hey, the data is already there, on those same machines. But at the same time, when you do that, you contend against the same system resources when those two very different workloads run. Right, like you don't want your analytics and your transactional workloads to use the same disks, to hit the same CPUs, because they will basically fight over those resources, and the loser will be the transactional workload that has tight SLAs. Right, so you never want to impact that like real-time ingest in Cassandra by hitting it with an analytics workload. So this is what happens when folks use Spark, and this is why folks kind of do a separate data center in Cassandra when they have Spark workloads, and even then. Separate data centers in Cassandra can still impact each other, kind of in extreme circumstances when you're running something big like an analytics app. So yeah, I think what you really want is isolation instead of co-location, and that's kind of what we get by making a system that just reads SS tables and Cassandra doesn't even know about it.
Sorry, go ahead. No, I just said I just saw another question, but before I answer, I just wanted to agree with you that I want everybody to see that with Cassandra and the work that we're doing, that these are complements. Like it's essentially taking the ability and capability of what Cassandra does and writing the data, particularly to an SS table, but there was a bit of a barrier between what you could do, take that data and then directly process it and push it into Rapids, before Alex came up with this kind of solution that now has been able to kind of integrate these two components and have them complement each other from the transactional side, and then move it quickly to the machine learning side. And then I've seen your question, this most recent question, where in the chat where it says, does Rapids avoid the data transfer between CPU and GPU memory? That's exactly what it does. And that's what Apache Arrow is offering now, is that we can actually now take this data and then push it into a GPU without having to load it to a CPU, which essentially would be the bottleneck, and then before you push it into a GPU for additional functional processing. So that's then the whole goal, is to then be able to then now keep all your analytics on the GPU, and essentially the start from everything from the ETL data wrangling all the way to your model training and iterative processing before you actually write it out to a particular destination, is to keep it all on the GPU without having to rely on the CPU for any additional functionality unless it's absolutely necessary.
Yeah, hey, you made a really good point on complementary that I really like, Justin. Like, we should have put a slide in here that just has like Rapids ecosystem and Cassandra ecosystem in like a little heart, you know? Because really what this is about bringing those two communities together. There's a ton of Rapids users out there right now that know how to take advantage of GPUs and their power, and they're reading data that's in JSON or CSV or Parquet format, probably mostly Parquet. And to get that data in Parquet, there's a lot of work that's getting done. And for a lot of large enterprises, the original source of that data is a Cassandra cluster somewhere. And somebody's reading data from those Cassandra clusters the slow way through CQL, and they're manipulating it with like some different tools to get it into that Parquet format so that they can go load it into a GPU somewhere. And so the stuff that Alex has built here is a huge shortcut to that kind of long process. And so we hope that the two communities, I think there's a lot of folks, definitely a lot of large organizations that have both a big Rapids footprint that's using GPUs for analytics, and a big Cassandra footprint where a lot of their transactional data is sitting in Cassandra. And so, the idea is to bring those together. Can you make a separate Cassandra replicated cluster? I think what you mean there maybe is a replicated data center within the same cluster that has the same data, to get the data to a certain snapshot state, and then get Cassandra to stop replicating and flush the data SS tables. Yeah, so operationally, you can tell Cassandra to flush at any point. Like there's a no tool command for that, and so you could, flush or take snapshots and kind of work off of those. I think there's different options that we can kind of operationalize or productionalize these tools. If this is something that's interesting to you, we'd love to chat more about it. So please do reach out. Like if somebody's actually wanting to use this for real, I'm Seb at DataStax. I'd love to chat with you. That's just SEB at DataStax. Another question: Do analytics in one batch and then switch to Cassandra back in full replication so it catches up? I guess there's different ways. But yeah, I don't think you might not need to do like Cassandra level replication to get the data out. Like you may, like the whole kind of one of the advantages of this is you can just rsync the SS tables and you're done, right? You may be able to just rsync those SS tables. You might not, you wouldn't need to use Cassandra to stream the data across to another location. So it may be simpler than what you're thinking there. Skivus 2000.
All right. Well, it looks like that is most of the questions. So I think we can move on. Was there anything else, Alex, that you wanted to talk about?
No, that was it. Thanks so much to Seb and Justin for answering those questions. And just keeping an eye on the chat. Yeah, that's it for me.
All right. Well, I think then we can move on to our quiz. If there's nothing else. Let me switch over here. All right. So for those of you who are still with us, looks like we still have most people, which is great. We're going to do a short little quiz here where you can win some prizes at the end. and get some swag sent to you. Now, we are going to be using menti.com. So you can see at the top of the page, actually, I'm going to bring up a bigger slide. So you go to menti.com, you can use it on your phone. You can scan that QR code if that's easy. You can also open a new tab. And you can enter the code that you see on the screen. I'll also put it in the chat. And you can join our quiz here. It's going to be a few questions. It won't be very long. But the top 3 scorers will be eligible to win some swag. And we ship the prizes all around the world. So no matter where you are, we can get it to you. So go ahead and go to menti.com. Once you're there, you can hit there's like a little thumbs up. If you want to hit that, we can see how many people are in. Let me go ahead and switch back. All right. We got some people. It's coming out of Justin's head, which is cool. All right. We'll give a little bit of time, make sure that everyone has an opportunity to join. I was going to mention something else, and I'm blanking on it right now. Seb mentioned that that you can reach out to us. I wanted to plug just briefly again our Discord community. I'll put that link in the chat as well. This is a place that you can kind of reach out to us and ask more questions and stay in contact. So that's a good place to join if you're interested in talking more about this topic or other topics, Cassandra specific topics. Be great. All right, it looks like we have most people in. So let's get started with this quiz. Now, something to note is that speed in answering the questions matters. So the faster you answer correctly, the more points you get. So keep that in mind. All right. So there's only gonna be 4 questions. And remember, the top 3 scorers will win. All right. First question. Oops. Went too fast. Answer fast to get more points. So what is the Rapids equivalent of pandas? QDF, QML, QGraph, or QSignal? And remember to watch your phone or the tab that you're in, because there's a little bit of a latency on the stream as well. All right, most people got that correct. It is QDF. Awesome. Let's see what our leaderboard looks like. See what the fastest answer was. Looks like Bastion was the fastest this time. Awesome job. All right, question number 2. Why are GPUs more effective at data science than CPUs? They have better algorithms. They have a larger ecosystem of libraries. They can run many parallel operations simultaneously, or they have more memory. All right. Awesome. Yes, they can run many parallel operations simultaneously, and that makes them more effective. All right, let's see where our leaderboard looks like. All right, looks like G was the fastest this time. Sash takes the lead. Bastion's in second, and Skivis is in third. All right, question 3. Which one of the following is not a benefit of using SSTable to Arrow? It reads data directly from files, freeing up Cassandra. It helps you migrate existing Python code using Rapids. It doesn't support all Cassandra features. It can read files from Amazon S3 and from disk. Remember, this is not a benefit. Which of the following is not a benefit? All right. Yes, it does not support currently all Cassandra features. It is definitely early in its development, but it's very promising, I think. All right. Let's see what that does to our scores. All right, looks like we had a tie for fastest, which is interesting. G now takes the lead. D is in second. Skivis maintains third place. All right, final question. This is for all the marbles. How does Cassandra save data to the disk? Arrow IPC file format, sorted string table files, Parquet files, or JSON files? All right. Yes, sorted string table files, or SS tables, is the correct answer. And let's see what that does for our score. And remember, if you are the top 3 winners, take a screenshot of your screen where it says that you have where you are in the top 3. And congratulations, G, to our overall winner. And then D is in second and Skivvis is in third. Make sure to take a screenshot of this page right here. And you're going to email jack.fryer@datastacks.com. I will put that in the if I can type in the chat. And you can email jack.fryer your screen here, your screenshot, and you will be able to get some swag sent to you. He'll reach out to you for all the details that you need for that. So awesome. Congratulations. Thank you all for joining us for this workshop and this webinar, and for participating in our little quiz here. We really appreciate you joining us. And unless there are any other questions, I'll hand it back to our presenters for closing us out. And we'll give you back the rest of your day.
Great stuff.
Thanks so much for coming, everyone.
Thank you so much.
Just want to note Alex's fearlessness in doing live coding on that session. Good job. It's not every day that somebody goes for it like that. Yeah, so that requires some courage for sure.
Yeah, well done. Well done, everyone. All right. Thanks, everyone, for joining us. We hope you have
Thanks for joining us, Justin. Really appreciate it, man.
Thank you.
Yep. Thanks for our special guest,
Take
Justin
care,
from Nvidia. Have a great rest of your week, everyone. See ya.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
Imagine a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.